use finite differences. That's like the idea of first and second and third differences to get info about whatever function or polynomial we're working with. So given us a table of values, to find finite differences, what we're going to do is first thing we need to do is we need to make sure that the change in all of the x coordinates are the exact same. If that's not the case, then we can't do these first, second finite differences. And usually what they do is they have it set up that way. So it is increasing by a value of 1. That's important. Is it increasing as we go through? If it was decreasing, that kind of changes the order we do the subtraction in, okay? So we started with the lowest x value, went to the highest. In other words, we kind of went, if this was the x-axis, we kind of went from the left to the right. That's pretty important. And it's changing by the same amount every time, okay? And in this case, it's the value of 1. If it was also changing by a value of something other than 1, we'd have to do a little more math involved. But anyways, x's check out. Y's. We need to find the finite differences. So what we're going to do, it's probably easiest actually, if we start from the bottom and we work our way up. And we just continuously subtract from the next value, So our very first difference is we take 48 and we subtract 18 and we end up with 30. Great. And we do the same thing again. 18 subtract 4 gives us 14. 4 subtract 0 gives us 4. 0 subtract 0 gives us 0. 0 subtract negative 2 gives us positive 2. Okay. Negative 2 subtract negative 12 gives us positive 14. And negative 12 subtract negative 36 is positive 24. Okay, so those were our first differences.
Wouldn't that be 10? Negative 2 minus negative 2.
It should be, oh, you're right. Oh, good call. Yes. I ended up adding both, but did I mess up the other ones too?
No.
That was okay. That should be 36, 24. Okay, that's good. So our first differences, they're not constant, so we continue the pattern, right? 30 subtract 14, and we get 16. 14 subtract 4, and we get 10. 4 subtract 0 gives us 4. 0 subtract 2 gives us negative 2. 2 subtract 10 gives us negative 8. And 10 subtract 24 gives us negative 14. Second difference is not not constant. We continue our pattern. I got more colors here. What have I used? So do green. Okay. 16 subtract 10 gives us 6. 10 subtract 4 gives us 6. Here we go. 4 subtract negative 2 gives us 6. Negative 2 subtract negative 8 gives us 6. And negative 8 subtract negative 14 gives us 6. There we go. So our third differences, they check out, they're all the same. So what does this tell us about the polynomial? It tells us that, so its largest degree is to the power of 3 because we found third differences, so we know that. We know because it's a positive 6 value that it has a positive a value here, so whatever's in front of that is positive. And then we can find the leading coefficient. The leading coefficient, we take our differences, so we'll call it d here, is equal to RA, because that's what we're looking for, times the power, so in this case the power, we'll call it n, factorial, okay? Sorry.
Factorial is when you take the whole number, so in this case it's to the power of 3. So 3 factorial would be equivalent of dropping by one natural number each time, so 3 times 2 times 1. You take it all the way down to 1. So for instance, if you had something like 7 factorial, it would be 7 by 6 by 5 by 4 by 3 by 2 by 1. So ours is 3 factorial. So it's 3 times 2 times 1, which we know will be the value of 6. So we're going to replace our n factorial, which is, like we said, 3 factorial, with the value of 6. And this d here represents our first differences. Or actually, sorry, our third differences. So because our third differences are also the value of 6, our equation is going to read 6 is equal to, a's are unknown, and then the n factorial is also 6. We have to isolate 4a, so when we bring 6 over, we divide by 6. Our a value is going to be the equivalent of 1. So what that means is the leading coefficient is positive 1. So what we know about our polynomial is that we have positive 1 x to the power of 3, and then we have something x to the power of 2, something x, and probably some constant value, okay? So the differences at least gives us our information about the leading variable's power and whether the function is positive or negative, and the leading coefficient.